Modern university students arrive in the lecture hall with minds conditioned by a rapid-fire stream of digital stimuli. Their attention is highly fragmented by design. To address this reality, many professors have integrated more audiovisual resources into their course syllabi, hoping to capture that elusive focus. However, a critical failure occurs when these materials are used without a pedagogical framework, such as playing a 90-minute documentary in class without specific guidance. Without active parameters, students often recognize these screenings as a break from the actual work. The video becomes background noise, a sanctioned opportunity to tune out. This creates a strange paradox. While flipped classrooms and hybrid models demand effective communication, universities are underutilizing the most potent medium available to them. Transitioning from an intuitive approach toward a planned strategy is a necessary step for maintaining academic rigor in a digital environment. Cognitive load theory identifies working memory as a narrow bottleneck restricting information flow. Poor audio or irrelevant graphics create an extraneous load that clogs this memory. Removing distractions allows the brain to process the intrinsic load, the necessary difficulty of the subject. Forcing a student to parse chaotic or cluttered media guarantees they will only achieve a superficial understanding of the material. A video only facilitates learning when its design respects the biological limits of human memory. Alan Pivio explained this through dual coding theory. The brain processes information across two parallel channels, one for verbal language, another for visual images. Activating both simultaneously and coherently helps the brain build a permanent mental representation. Richard Mayer developed an engineering blueprint to achieve this coherence through a set of multimedia principles. The principle of coherence requires eliminating decorative images or background music that distract from the message. The screen clears to show only essential data. Then, the principle of segmentation fractures long lectures into digestible 3 to 8 minute conceptual blocks. Adhering to these principles transforms a raw video file into a tuned instrument for cognition. While cognitive science determines the format of the video, academic strategy must dictate its objective. Bloom's taxonomy provides the map for that strategy. If the objective is to remember a definition or a date, a tight 2-minute micro-learning clip is the ideal tool. Moving up the pyramid to comprehension requires specialized animations that can reveal invisible or abstract processes, showing them clearly in motion. Reaching the level of analysis demands a longer documentary case study, perhaps 10 to 15 minutes, to challenge the student's critical thinking. Matching the cognitive objective to the precise video format is the hallmark of a strategic educator. A video is not the lesson itself. It is an event situated within a broader instructional sequence. To prevent passive viewing, professors can utilize a 3-part roadmap: before, during, and after the screening. Before pressing play, instructors should activate prior knowledge and provide students with specific observation goals to guide their attention. During the video, visual signaling and strategic pauses help maintain engagement and allow the brain to process information in real time. After viewing, the material is processed immediately through activities like debate, mind mapping, or applying the concepts to a complex problem. Creating an environment for true active learning does not depend on high production values or the latest technology. Educational innovation is the result of deliberate planning and the alignment of teaching methods with how the brain actually learns. Aligning cognitive science with clear learning objectives ensures that audiovisual resources function as effective instruments for intellectual discovery.